So we're going to move away from solving equations, and we're going to add some different things into this unit because they kind of had no home, and this unit was a little on the shorter side. So we're going to be learning about law of cosines and law of sines. Most of you should be familiar with these from before. I'm pretty sure that Mustoha taught them. I don't know if you learned them in geometry or not, but I'm going to teach them again as if you haven't seen them before. Most of this stuff is not really hard, but it is pretty, there's a lot of writing involved. Even as I was writing on here, I just realized it's just a lot of work. It's not hard, you're just following formulas, but it's a lot of work. So, the law of cosines, it's basically how to solve triangles that are not right triangles, okay? Law of cosines and law of sines will allow us to do this. So, the law of cosines says that in any triangle, ABC, this is any triangle, it does not have to be a right triangle, a squared equals b squared plus c squared minus 2bc cosine a. All right, and I know this looks super complex, but as long as you have the formulas, you can solve them. Notice they follow a pattern. Okay, whatever this variable is, this little a, it's going to be the cosine of the big A here, and these two variables are going to be the other two, and it doesn't matter the order. Same thing here, b squared, big B there, a and c are these ones. C squared, big C, A, and B are these ones. So down here where it only gives you one, cosine of A equals B squared plus C squared minus A squared over 2BC. If you were to change this to cosine of B, then this would become A, this would become B, and that would become A. Alright, so the variable here is the one that needs to match up with the minus. The other two don't matter the order, just as long as they're both there. Alright, so these two forms, we're going to use these forms to solve triangles. So example 1, okay, we have a triangle. I always draw the triangle. I'm not going to draw it to scale or anything like that, but just realize that so B is 40 and B is the side that we don't have, so we need to find little b. We also need to find A and B. So when we say solve the triangle, it means you need all the pieces. So little b squared is a squared plus c squared minus 2ac cosine b. I'm going to plug all those numbers in. I'm not going to say all those numbers, but I'm plugging all the numbers in. I'm plugging a into a, c into c, and so forth. Okay, and then the cosine of 40. And I'm going to plug that all into my calculator. So make sure that you get this stuff written down, though. And I end up with b equals 13.3. Now, once I have this information, I can now use the alternative form of the law of cosines to find these two angles. All right? So I'm going to go with the cosine of A. I'm going to try to find A first, and it really doesn't matter which one I use. So the cosine of A is b squared plus c squared minus a squared. Remember that these two letters, the big A and the little a, must match up. These two don't matter. And then I'm going to plug in all those numbers. Again, I remember writing this, and I was just like, oh, it's just a lot of writing. So it's not hard, it's just a lot of writing. Plugging in the formulas. So, and once I have this, I'll be able to use my inverse function to find the actual value. So I find this number, and then I do the cosine, the inverse of that, and I end up with 35.5. Oh, one thing. With these values, make sure that these are degrees. So change your calculator back to degrees. All right. If this test is going to be interesting because you'll have to go back and forth between degrees and radians. All right, now for this one, I'm not going to go through all of this work. I'm just going to go 180 minus 45 minus 35.5 to get me my other angle. So I want you to realize that you're given 3 pieces, you need to find 3 pieces. All of your problems will be like that. Given 3 pieces, find 3 pieces. Okay, so here's a practice problem. Go ahead, pause the video, try it on your own, and I'll walk over the solution with you. So here's a solution. Again, I simply plugged into a formula. I was looking for c squared. I plugged it into the formula. I solved. I got c equals 21.6. Then I used the alternative form of law of cosines to find, I plugged everything into the formula, got my answer. Then I took the inverse to get my angle. And then 180 minus 42.2, and then 110 gave me 25.8. Again, remember that your calculator's in degree mode or you're going to mess it up. Okay, example 2. I think this is a long one. We have 3. Okay. So now, this one gives me all 3 sides. So this is a different type of problem. The last one we did was a side angle side. This is a side, side, side. So since all I have is sides, I have to use the alternative cosine formula to find this. So, and I will have to do it twice. Once I have the two angles, then I can do the third one with the 180 minus those two values. So, and it really doesn't matter which one I start with, you'll get the same answer anyway. So cosine B equals 8 squared plus c squared, 8 squared plus 10 squared minus 5 squared over 2 times 8 times 10. Okay. Throw that all in a calculator, and I end up with, okay, that B equals 29.7. So I have one angle. Now I'm going to do it again for a second angle. It really doesn't matter which one. The answers will be the same. Decimals might be off just a little bit, but as long as they're close, you'll be fine. So I'm going to go with C. Right, a squared plus b squared minus c squared. Again, remember that the only one that matters is this one. Those two have to match up. So 8 squared plus 5 squared minus 10 squared over 2 times 8 times 5. Okay. Then I take the inverse. Don't forget to take the inverse, and it is 97.9. So I'll plug that in, and 180 minus 29.7 and minus 97.9 is... Oh, I got ahead of myself. I think I had to run and get my calculator at this point because I didn't have this worked out on my paper. Sorry. So, anyway, whatever this is, we're getting there. Oh, I can fast forward, I forgot. There we go, 52.4. So, that's my last angle. So again, lots of work on these problems. You do need to show your work, okay? I don't necessarily need to see the formulas, but I do need to see the work. Here's your practice problem. Try it out. Let's see what you get. All right, here's the solution. Again, all I'm doing is plugging into formulas. I'm not sure, what I need to go over, other than the fact that make sure you're taking inverse. It's set up slightly differently, but as long as you're plugging in the formulas correctly, you should be just fine. And now we're going to get into fun stuff. Okay, so this is such a great problem. But it does take into account that you need to have some prior knowledge about north, south, east, and west, and those things. So we have a plane. The plane flies west from Cleveland at 350 miles per hour. A second plane leaves Cleveland at the same time and flies southeast at 200 miles per hour. How far apart are the planes after 1 hour and 36 minutes? Now, there is work that has to be done before I can actually start solving this. So first of all, we need to figure out we have no angles, okay? And we have no sides. We actually have to find all of them. So let's talk about north, east, south, and west, okay? If you do not know a compass, you need to figure that out, all right? So anytime we have these, they're 90 degrees, okay, because they're right angles. And then if I'm flying southeast, okay, I'm going exactly halfway between south and east. So I have a 90 degrees and a 45 degrees. So if I'm going from the west to the southeast, it's 135 degrees. That is my angle. So I am going to the west, southeast, 135 degrees. That's the first thing. The second thing is I want you to realize that these are not distances. This is not 350 and this is not 200 miles. It's 350 miles per hour. Okay, I've flown for 1 hour and 36 minutes. That's also not 1.36, okay? It's 1 hour and it's 1 hour and 36 over 60. I think I thought I did that on here. So I have to multiply those together. Oh, here we go. All right, so let's talk about this. So to get 320, I did 200 times 1 hour and 36 over 60. All right, that is important. This is not 1.36, okay? And the same thing here, 1 hour and 36 over 60. And I got these distances. That's how you find these distances. So I have, at 135 degree angle, I have this plane flew 320 miles, and this plane flew 560 miles. And I need to know this distance. How far apart are they? Well, this is now simple because I have a side, an angle, and a side. And all I want is this side. So I don't actually have to do the work for the whole triangle. I don't care about these angles. I just want to know this distance. So I'm going to use my cosine formula. I'm going to call it c squared. Okay, so c squared equals 560 squared plus 320 squared minus 2 times 560 times 320 times the cosine of 135. Calculate it all up. Now you end up with a distance of 818 miles per minute. So anyway, really, really great problem. I realize that this is a tough problem, but I would expect that you will see a question like that on a test. All right, so here's another one. Two trains leave the station on different tracks. The tracks make an angle of 125 degrees with the station as the vertex. Now this is nice because it gives you the angle. The last problem did not. The first train travels an average of 100 kilometers per hour, and the second train travels an average of 65 kilometers per hour. How far apart are the trains after 2 hours? Again, this is a little bit simpler because we have even number. Okay, if this is 100 kilometers per hour, think about how long it travels in 2 hours. Okay, if this is 65 kilometers per hour, how far does it travel in 2 hours? Draw yourself a triangle and see if you can come up with the answer. All right, so here we go. So we have 130 is our distance here, 65 times 2, and this is 200 because 100 times 2, and it's 125 degrees. So this is, and then we want to know how far apart they are. Okay, plug them into the formula, because we're looking for c. C squared equals 130 squared plus 200 squared minus 2 times 130 times 200 times the cosine of 125. I would calculate that all in one step. This works it out for you. And yet the trains are 294 kilometers apart after 2 hours. And I will see you tomorrow.